Hey everyone, I'm here at the SoDo Makerspace today working on some wearable projects, and this is a carrier board that I designed for the NeoPixels that Adafruit sells. I went ahead and added a couple of little holes here for doing sewing, and then also a slot which I'm going to try out to see if it'll hopefully stabilize the ribbon cable that I've been using for these, so I don't get any solder breaks when things get flexed. So we'll see how that works out, but you can see the basic design has room for the capacitor and then the 4 pads for the NeoPixel, with the whole plate being a common ground, so it helps out with routing on a single face board. Now I am not going to be using the milling path for this. This is just for reference for another program, but I'm going to show you how I generate the path. Go here to PCB G code, hit open, and I've already got my settings put in. I'm going to generate the outlines of the traces and then also the drills. I'm also going to be doing text because I do have some reference text on the board there. We're going to go ahead and accept and make the board. You'll see it'll build it out. There's my preview right there, so I can just double check real quick to make sure all my traces are completely isolating my circuits, and everything looks good from there. So I can go ahead and close that window, and it should show me my text layer next. So you can see there's a whole bunch of reference text that I have in here to show what direction the data is going in, and then a couple of little slight cutouts for that grounding pad, and also a little reference to show me which way I need to orient the NeoPixels. And we're going to close that. Now it's going to pop up the bottom text, which I don't have any. It just does that by default. And that's the toolpath. Okay, so now we have our toolpath generated for the CNC mill for outlining the traces, doing our hole drills, and also doing some of this reference text on it. Like I said, I don't like doing the outside milling of the board, which would be the final cut all the way through, because this plug-in will only do a single pass. It's really tough on the machine, and I haven't had much luck without going really slow. So I have a better program for that. What I do is I'm going to go up here to File. We're going to do Export, and we export as a DXF. Check inches and hit OK. Now I've already done this, so it'll ask if I want to rewrite the file, but I have Aspire here, and Aspire is a program just for writing code for a CNC mill, and this is going to be the final cutout for my board. If I go up here to import, and I import vector, I can look for the DXF that I just exported. And as you can see, it's going to import it, and that's my circuit. So I can see that it does line up, and that stuff will be in the center there. And it's just a lot easier to do outside cuts with a program like VCarve. Plus, I can do multiple passes with that. So I have this set to do 4 passes. If we go and look at what the toolpath looks like on that, you'll see that for the outline we have multiple passes it's going to take. So it's going to take some pretty shallow cuts, and then I also have these little keys here which should keep them stabilized as they're getting cut out. We can do a preview of this, and actually I'm going to do a preview of both of these. So I want it to do all my drills, the interior cuts first, and then finally do the outside cuts. So that's why I have the 2 toolpaths. And if we go ahead and go to our preview here, let me reset our preview. So this will kind of give us a test run. I can slow the speed down so we can see it kind of fast, but you'll be able to see what's going on. And then we're going to do preview all toolpaths, and you'll see basically it'll run what the machine will do here so I can see if there's going to be any troubles and what order it's going to come in and roughly what the final product's going to look like. I'm going to speed it up just a little bit so we can see. So you can see it's doing those cuts first, the inner ones, and now it's doing the outside cuts. And you can see the little tabs that it leaves in there. That's so that it doesn't pop out, because we're doing a pretty small cut, but it's still 1/16 of an inch, which gives it enough to move around. So we want to prevent it from doing that. And then that is what our outside cuts are going to look like with the circuit board in the middle. So I think we're ready. We've generated our tool paths, and time to move over to the CNC. Okay, one thing I needed to point out, which I forgot to mention, is that that plugin for EagleCAD works really well, and the etch file, that's what does our traces, that will work fine, but I have run into this comment, well, this row of comments here. It's just a little too big in order to for the machine to run it, so it usually ends up with a code error there, just saying that that line, the comment is too long. So I just go in and delete it. It's just a standard G-code file, so you can edit it with any text editor. That should be fine. We'll hit save, and now we should be able to run these files. So these are all my G-code files. Like I said, we're not doing bottom text, so we're going to delete that one. But we're going to run each one of these 4 files. So we're going to do the etch first, which is going to use our engraving bit. Then we're going to run text, which is also going to use the same engraving bit. Then we're going to switch our bits out to the drill and run that file, and then we're going to do the final mill cut, which will be that one. So I'm going to go ahead and save those to a thumb drive, and we'll move over to the Shapeoko and let you see that in action. Because I'm doing really small traces, what I wanted to use is a very, very small bit. I believe this is a 25-degree engraving bit with a 0.2 millimeter tip on the end. So it's very super tiny. You can barely even see the flat spot on it. It's very hard to get this so that you know it's right down on the copper plate, but because we're using copper, there's a cool thing that we can do. I have this hooked up to a voltmeter, and it's set to basically buzz whenever it makes contact with the 2 leads. I've got the ground on the copper plate and the other one clipped to the mill, and you'll see as I bring this down, when it touches, you should hear a beep. And there we go. So now we know we're touching that copper plate, and if I back it off just a bit, now we know that we are exactly right over that copper plate. That's zeroing the bed, and that should turn out perfectly. Okay, so I have the file loaded for doing the etching, and this is actually on a Raspberry Pi, which I now have hooked up to take my G-code and to operate the Shapeoko. I haven't ever tested this before, so this will actually be the first run of driving the Shapeoko 2 with the Raspberry Pi. So because I don't want to break one of these bits, they are kind of expensive. You'll notice that I have this thing raised up quite a ways above everything, and I'm going to do a test run. It's always a good idea if you've never run the machine before, because then you don't have to worry about breaking bits. So everything should be loaded. Let's go ahead and hit begin, and we should see the machine start to move, but it should not get below or come anywhere near that board. But we do see it moving. You can see the toolpath there, and everything looks like it's working just fine. So I'm gonna go ahead and zero this out and see if we can get the mill carving. Okay, we are all zeroed out now, so we are in our starting position, and you can see our program is loaded. Everything says 0. We're set to go. What I'm going to do is I'm just going to start our spindle. You'll hear it spinning up now, and then I'm going to go ahead and hit begin, and now we're going to see the machine start to do its carving. Okay, it looks like we had a problem before. I didn't clear a bunch of errors. So what we're going to do is we're going to load that file again. So load our etch, open, and then if we go over to advance, we want to unlock durable, which sends the $X, which should clear out all of our errors. Now we should be able to start our spindle and hit begin, and now we're moving. So you'll see that white powder that comes up. That's exactly what we want to see. That means that it's getting through the copper and into the board itself. Now this board is not made of glass like a lot of the different types are. If you're doing one that's made of fiberglass, you really want to wear a mask to protect from the dust. This is just paper. It's a paper-based board, so you don't need a mask. It doesn't actually really kick up a lot of dust. I wouldn't inhale it, but like you can see, it's not really kicking up any dust, so you don't really have to worry about it so much. So I'm going to let that go, and we'll let you have a look at it once we get ready to do the lettering. Okay, I vacuumed off some of the dust. You can see there's still a little bit there, but just so you can have a look at what it did to basically clear out the traces. I think that's plenty of room for my soldering there. I think just about anyone would be able to solder something like that. So let's go ahead and move on to the text carving and see how that goes. So as far as the machine, we don't have to do a tool change in order to move over to the text carving. Instead, what I'm going to do is I'm just going to go ahead and load up our top text file. And you can see now we have our new toolpath. We're using the same tool, and since we're already 0 leveled, we're going to go ahead and just run this job, and it should work out fine. I'm going to start up the spindle, and we just hit begin. Do you want to 0 the display position before beginning? I'll have to check that one out. Alright, so it looks like the correct answer to that question was no. I guess what it was asking was, do I want the current position of the machine to be 0? Since the G-code from our last run didn't bring it back to 0, it just kind of stopped where the toolpath ended. We did not want to have that toolpath be 0. So I just hit no, and it brought it back to the last 0 position the machine had, which was where we started. So that's a good thing to note, and I'll make sure to document that for this program. Okay, it may be a little difficult to see. Let's see if we can turn on the light. But I wanted to show just how fine a detail this machine is doing. These letters are very, very tiny. Each one of these mini circuit boards is about the size of a penny. So yeah, the Shapeoko can do a really, really good job at super fine detail work, and I just wanted to show that here on camera. I'll go ahead and wipe down the board so you can see what happened at the end. Alright, so our lettering is all done. We have a couple little arrows there to point what direction the data goes in, and you can see we have our ground and voltage labeled, as well as a couple of partial contacts that we're using for the ground. Now, just for reference, I wanted to show you just how detailed it gets. So this is the eraser end of a pencil. Just to give you some sizing reference as to how big these things are, or how small they are, rather, and how much detail you can get. Each of those letters is probably about 0.3 millimeters in diameter, or the width of the line is probably about 0.3 millimeters. So yeah, you can get super fine detail here with the Shapeoko, and this really fine, and that's not even the finest bit. I could maybe even get smaller lines if I wanted to. We're gonna try a higher pitch here in a couple of days, but yeah, I'm gonna go ahead and switch to the drills and we'll show you that in action. Okay, so now we are switched over to the drilling bit. I'm pretty much only going to drill one size hole. This is the one that I found that works the most. I can't remember exactly offhand what dimensions it is, but all my drill bits are color coded, so I know which one I typically use. I was very careful not to move the machine itself while I change the bit. Now I'm going to go ahead and select my drill tool path. We're going to open that, and you can see the path it's going to take to drill all those holes. Let's go ahead and turn up the spindle, and we're going to hit begin. We are going to hit no because we want it to return to its original homing position, and you can see there is returning to that position. And now it's going to go and should start drilling our holes here. So these are grounding holes. They're what ties us into the ground plane. They don't have any traces in there. This thing, like I said, it's pretty precise, so it will get those holes pretty much dead center inside the traces, and I just wanted to show you that. And as you can see, those holes are pretty much dead center where they needed to be. This thing really does an amazing job. Okay, so as you can see, we've switched to our 1/16 inch end mill. This cut is usually pretty terrifying for me because everything else is done, and using the end mill to cut out things usually puts the most stress on the machine as you can. So the potential for things going wrong is probably most in this step than any other. But I think I've done this enough times. I think our settings are pretty good. So let's go ahead and go over. We've already loaded up the file. I'm going to turn on the spindle, and we're going to hit begin, and we'll see how it goes. Oh, yep, we got to hit no because we want it to start from the original home position. And let's see how it goes. It's going to drill those holes first sewing holes, and then it's going to mill out the slot. And yeah, you can hear that vibration. The more vibration you get there, the more it means that there's stress on the machine. The machine can handle it. It's more just if you get too much of that stress on the machine, it'll get out of alignment, and as soon as it gets even a little bit out of alignment, then you're all messed up because our tolerances are pretty tight. on this board, it's pretty small, so even a fraction of an inch getting offset here could mean the death of these boards. But everything's looking pretty good so far. That's one of the reasons why I'm doing all those multiple passes. The more passes you take, the thinner layer of material it's removing, and that puts a lot less stress on the machine. It's mostly going those sideways paths that causes the most stress. And because we're just shaving a little bit off during each pass, that makes things go significantly smoother. And of course I've put all of the settings that I typically use for this kind of job up on my website, and whenever I do a tutorial for this kind of stuff, I always post those settings as well. But everything looks like it's turning out pretty good so far. So I might just speed up this footage a little bit so you don't have to sit here and wait. Now that we're all done with the mill, here's one of our final chips, all cleaned up. There were a couple of issues. The holes didn't get drilled quite all the way through on the final passes, so those sewing holes on the side I had to kind of just take an X-Acto blade and finish out. But it turned out pretty good. And here is one with a NeoPixel soldered onto the board. And actually those tabs on the side work really well for holding in my cable. I've just been using ribbon cable. You can get it for fairly cheap, and it holds the wires together really nice for doing long runs. But as you can see, the NeoPixel is working. The pads were a little small for doing hand soldering, so I might actually do a few changes and just make those pads a little bigger. But the circuit works, and that's what I was really concerned with. So I hope you liked seeing this in action, and we'll see you on the next project.